Welcome back to Number Math, in which we apply color to identify and sequence within math, always providing our viewers the opportunity to solve independently and self-assess with an answer key at the end of the video. My Math 2 crew, this is your 5.1 to 5.4.1 review. Kicking it off with number 1 says find the endpoint. Okay, to find this endpoint, I created this little formula here. We are solving for x subscript 3 and y subscript 3. I'm done saying subscript. We're just going with x3, y3, okay? So if I'm a student taking notes, I'm going to go ahead, I'm going to put EP, represented our endpoint in which we're solving for, all right? And we know we're solving for it because it's also going to be our x3 and y3, little arrow here, all right? Set up our parentheses for when we do discover our answer here. Now let's read through together. One endpoint of a line segment is 2, 6. Whoa, critical information here. Endpoint, highlighted in blue, 2, 6 is blue. Now our formula tells us that that 2, 6 will be our x1 and y1. So if I'm a student taking notes, endpoint given, I will write as EP. And I'm like, okay, well, that's going to be my x1 and y1. And we do know what those are. All right, it's 2 and 6. So I'm just going to put a 2 and a 6. I like to label above. Some students find that to be a little stronger for them, so please feel free. The midpoint of the line segment is -3, -8. Oh, the midpoint. Okay, so now it's giving us another key piece of information, and it's in red. That's going to be our x2 and y2. So again, if I'm a student here and I'm taking notes, I'm just going to go ahead and put MP. And I'm going to put x2, y2, my little arrow, my brackets, my parentheses, -3, -8. And again, if you're more comfortable, go ahead, put the x2 and y2 right above or right below, whatever's best for you. Then we will simply plug and chug along with our formula. Again, we do not know what our x3 is. So we're just going to follow the formula. We're going to write x3. Okay, we are going to set that equal to our x2, which we've identified as -3. So we're just plugging and chugging along. We will multiply that by 2. Then we will subtract our x1 value, which we've identified as 2. We will set that equal to, do the computation you already may have. -3 times 2 is -6. Subtract another 2 from that, we have -8. Go ahead and plug that in. Ooh, I don't like how that's in black. I wish it were in green. Sorry about that, guys. Go ahead and plug that in. All right. Now we just do the exact same thing, but with our y3. Sorry, sometimes it auto switches to our eraser, and it does that quite a bit. I wish it didn't. Then we will plug in our y2, which we've identified as -8. We will again multiply that by 2. And again, we will subtract, but this time from our y1, which we have identified as 6. Set it equal. Now going through, -8 times 2 is -16. -16 minus 6 is -22. And that right there in green is your answer. At this time, I would pause the video, take any key notes that you find critical if you missed any, and take a look over to the right and try to work through it. Do the best that you can, okay? Because just identify endpoint. What do we label that as? Exactly x1, y1, and our midpoint is x2, y2 because we're solving for x3, y3. All right, moving forward, number 2. What is the scale factor of the dilation pictured below? All right, I'm going to highlight a key term here, scale factor. When I think of factors, I think of multiplying, All right, so we might be finding something here. Maybe a multiplier. We might find that through dividing. Let's take a look though. Let's write the note. Scale factor. Now, our scale factor equals our image over our pre-image. Now, our image is our A prime, B prime, and C prime. What do we notice about that triangle as well? Yes, it does have a dashed line. So what we're going to do is, and then because it's in red, I'm just going to put image. Now, there's two ways. These are the prime numbers, prime coordinates here, or we can put dashed line. Whatever works best for you. I feel like dashed line works best for a lot of students, so I'm just going to go ahead and put dashed line. All right, we will put that over our pre-image, the image that we started with. That's in green. And what do we notice about that? Yes, it is. It's a bold line all the way along, or solid line. All right. Now, if we know it's looking for the scale factor, we don't have to test them all. We only have to test one. All right, what I like to do here is I just like to take a look at our coordinates. All right, we're going to look at our B of 6, 8 and our B prime of 1.8 and 2.4. We're only going to look at the X coordinate. That's all we need to do. Now, if we are setting the image, which is our prime, and if our X coordinate for our B prime is 1.8, I just want to write 1.8. Okay, we are going to set that over our X coordinate of our B, which is our pre-image of 6. In our calculator, we just do 1.8 divided by 6. Gives us 0.3. That right there is your scale factor, and that is your answer. Now, something else with scale factors. If that number is less than 1, well, our image is going to get smaller. And take a look. Our pre-image is a big one. We multiplied it by 0.3 each coordinate, and it shrunk a little bit. It got smaller. That's because the scale factor is less than 1. If the scale factor were greater than 1, it would enlarge. So make sure to check that when you go through. All right, take down the keynote, pause the video. We will scroll down for your practice. And again, at the end of the video, we will provide the answer key. Moving forward to number 3. It says identify the similar triangles. Okay, I'm going to give you just a tip and a trick to solve this. What we're going to do is we're going to take a look at triangle BAC is similar to triangle EFD. All right, which statement is best? We're going to use what I like to call a number system. We're going to look at triangle BAC. We're going to look at angle B. Angle B has one arc or one arch curved. I'm going to put a 1 above it. Now, angle A, what is that square? Well, it's a 90-degree angle. I'm just going to put a 9 to represent our A, and our C doesn't have an arch or a square, so we're just going to put 0. Okay? Now, if the similar triangle statement works, this will follow 190. Well, let's check. Okay, triangle EFD. Angle E is represented by, what will we use, guys? One arch. Yes, exactly. Just go ahead and put that 1 above. Now it goes to angle F. Angle F, doesn't have anything. We're just going to put a 0 above. And then our angle D is represented by that 90-degree angle. We'll put the 9 above. All right. Is 190 the same answer as 109? No, it's different. Get rid of it. Now, going through this, I did make an error. This is the exact same answer choice. Go ahead and get rid of B as well. Let's check C. All right, we will look at triangle CBA. All right, and just like on your test, guys, they're going to mix up the angle letters. So using the number system will solve it 100% correct every time. All right, let's take a look at angle C. Angle C, again, yes, we will put a 0 above it. Angle B, 1 arch, we will put that 1 above. And angle A, that 90, we will put the 9 above. Great job, guys. All right, triangle FED. Let's take a look at angle F, represented by a 0, Wonderful. Angle E, whoa, hold your horses. Yes, it is a 1. And angle D, of course, then will be our 9. Is 0, 1, 9 the exact same order as 0, 1, 9? Yes, it is. That right there is your correct answer. If you apply the number system to this as well, go ahead, please, and try it out. What I'm going to do for you is I'm going to put in a little angle right there. Oh, let me go back. Let me put one there for you and one right there for you. Sorry about that. Go ahead and work through it. Now for number 4, it says, which statement would justify triangle ABC is similar to triangle DEF? All right. Which statement would justify triangle ABC is similar to triangle DEF? All right, well, let's take a look. I just like to mark these up a little bit and just follow the pattern of what it's giving to me. All right, well, I do know that angle A is represented by an arch, so I'm just going to put angle. Then we run right into a side. All right, then it has a 2 arch. That's going to be another angle. Let's take a look. All right. Oh, whoa. So angle A and angle D are congruent angles. That's represented by an angle. It also has the side here. And then an angle B is congruent to angle E. So once we know we have 2 congruent angles within 2 triangles, that means they are similar triangles. So your answer is going to be something along the lines of angle, angle. All right. Oh, look at answer choice A, angle, angle. Go ahead and circle that as your best answer choice. All right, taking a look at your practice on number 4, do the best that you can. Pause the video, work through, see what you can do. All right, moving forward, number 5. Which statement would justify triangle QRS is similar to triangle TUV? Again, let's just go ahead with the marking system, okay? All right, I'm going to start here with the 2 ticks alongside QS, and I'm just going to put an S to represent side, okay? Now, whoa, this Q does not have an angle. I just added that there in black, and neither does this S in following the pattern, so let's just get rid of that. That does not work. So it goes side, should be an angle, and then a side, and then an angle, SSA. Does anything represent side angle? Well, we have side angle side, but side angle does not work. In angle, there's no side here, so that wouldn't work either. So let's get rid of that. Let's get rid of this, and let's just go ahead and put can't determine. Once you figure out that just the first triangle you're looking at is not providing you enough information, it won't be similar to the other triangle because there's just simply not enough information. All right, pause the video. Take a look at the information it's providing for you. All right, is it angle, angle? Is it side, side? Is it side, angle, side? Can it not be determined? I don't know. Are the sides proportional? Is there enough angle action there to tell you that it's angle, angle? Go ahead and give it a shot. Moving forward, number 6. Given the points 15, -6, and -3, 13, what are the coordinates of the midpoint? Okay, the coordinates of the midpoint are just going to be x1 plus x2 divided by 2. All right, so what I like to do is identify. I like to label. Now, I will label in blue x1, y1, and then I will label in red x2, y2. And it simply just says to do x1 plus x2. So x1 is 15. Will we do plus -3, or can we just subtract 3? Exactly, we can just subtract 3. All right. Then we will do -6 plus 13, because yes, it is positive, so -6 plus 13. Okay. Do a little line here. 15 minus 3 is 12. Great job. -6 plus 13 is 7. Awesome. Are we finished? No. Now we just have to divide each by 2. Okay. 12 divided by 2 is 6. 7 divided by 2 is 3.5. 6, 3.5 is your midpoint. Go ahead and circle your answer. Guys, simply just take it, align it right below, do the computation, divide by 2, and that's your midpoint. That's all it is. Go ahead and pause the video. Try number 6 here independently, and you will see your answers at the end of the video. Number 7, whoa, what does it say? Determine the scale factor again. And I think we're pretty confident this time around. However, I'm still going to write the formula below for us. All right, scale factor equals our image. Does anyone remember what our image would be here? Would it be the smaller triangle in red or the larger triangle in green? Yes, it is the larger triangle in green. Why is that? Exactly. The prime. Great job. A prime, B prime, C prime, and yes, it's also dashed. So we're going to put image, dashed line. We will set that over our wonderful pre-image. Solid line. All right. Now we just have to find the corresponding sides. You can choose whatever you would like. Okay. I don't really want to prefer to work with decimals. So guess what? I'm not going to. So I'm going to take a look at A prime, C prime. That's represented by a 30. We will set that on top. All right. We will divide that by AC of our pre-image, which is 8. Now, in our calculator, if we do 30 divided by 8, we get 3.75. And that right there is your scale factor. That's your answer. That's how simple the two scale factors are. Go ahead and pause the video. Try this next one independently on your own. All right, but that should be no issue for anyone at all. I mean, this whole quiz, guys, 9-ball corner pocket. All right, there's 9 questions. We have 2 left to go. This should be an easy W, an easy hundo. If not, an 88.8%. All right, moving forward. Number 8, it's asking us, what is the length of RS? Okay, so RS, we don't know what RS is. Whoa, but there's nothing there. Well, what can we do? Exactly, we can just put a variable there. We always prefer to use X, and that's exactly what we're going to do. Okay, now, here's the deal. Do you have to write the proportionality statement? No, you technically don't. If you can plug and chug along and you're comfortable going with it, great. However, for those that are still a little unfamiliar, I will write the statement for us, okay? Now, when I write the statement, I always like to start with what it's solving for. We're looking for RS, so I'm just going to put RS, and I am going to set that over the corresponding side. All right, which in this case will be our UV of 9. So we'll put UV. All right, we will set that equal to, if we started with green or with our larger triangle that we were solving for, we want to take the other information that it's giving us, which I'm circling is at 17.5. We'll label that QS. All right, and then we will set that over TV. No, I really don't watch a whole ton, thank you. All right, then we just plug and chug our numbers, okay? RS, what is it? X, wonderful. We will set that over our UV of 9. Yes, wonderful. Equals, what's QS, guys? 17.5, wonderful. We will set that over our TV of 7. From here, great job. Thank you. Yes, we do cross multiply. I always like to start with the variable when crossing, and I will write this out completely how it should look. But do we know what 7 times x is? Yes, it is 7x, but I'm still going to write it out. Thank you all so much. We will set that equal to 9 times 17.5. All right, we will work through the math. 7 times x is 7x. Set that equal to 9 times 17.5, which gives us 157.5. All right. From here, we will, yes, exactly, divide. What are we dividing by? Yes, it is our 7. So x equals 157.5 divided by 7, which gives us 22.5. All right. Now, the shortcut that we went over in class, you will have it available. I might demonstrate it on the next one. All right. So when we solve it proportionally, we solve for x. All right. Now, x in this case is also our side length, but in the next problem, we'll see that you can solve for side length and variable. So solving proportionally gives you the solve for the variable. But if you solve using scale factor, you're solving for side length. Okay, when I solve for scale factor, I like to look at, well, which triangle am I solving for? If we're solving for RS, we're solving for the larger of the two. All right, you can simply take the other piece of information it's giving you, which is 17.5. You can divide it by its corresponding side of 7. Hit enter in your calculator. It's 2.5. Go ahead and hit times 9. Is your answer still 22.5? Yes, it is. That's how simple it is. Setting up the proportion statement. All right. Writing the proportions, cross multiplying, dividing. It can take a little bit. All right. But if you just do 17.5 divided by 7 times 9, take a look. It's just a proportion. 17.5 divided by 7 times 9. 22.5. Wonderful. All right. I will provide the shortcut on this one when I go through it, just to give that for you. All right. Now, quick question. Are we solving for the smaller triangle or the larger triangle? Exactly. We're solving for the larger triangle. And why is that? Because the larger triangle has variables in it. All right, so we don't know that. Plus, it's also telling us to solve for QU. QU. And we do have enough information to take the scale factor out and find the side length before we find the variable. But let's go ahead and look at it, okay? If we're solving for the larger triangle, we want to take the piece of information that it's truly giving us for a side length, which is 28. We will take our 28. We will divide that by its corresponding side of 8. All right. Let me make that division symbol a little better. And that equals, so let's do 28 divided by 8 equals 3.5. All right. That's our scale factor, just like we did before. Now, if we know that two triangles are similar, guess what? Every side is proportional. You know what that means? They share the same scale factor. This is just such a quicker route, okay? Use it. 28 divided by 8 equals 3.5. We will take that 3.5, which is our scale factor. I'm going to put a little SF above it, just as a reminder for us, okay? Now, if we're solving for QU, we want to multiply that scale factor by QU's corresponding side. Take a look at this Q. I put it in blue because it plays with both triangles, okay? So from Q to U, we go from 1 arch to 2 arch. In our smaller triangle, all right, is it QR or QS that goes from 1 to 2? Well, QR goes from 1 to 1 to 3. Can't be that. So let's go 1 to 1, 2. So we will take that 3.5. We will multiply it by that 9 right there. All right, so let me do this. In your calculator, just hit times 9. hit enter. That right there is your side length. That equals QU. So 31.5 is the total of QU. Okay, so they're looking for, well, what number plus 22.5 equals 31.5? If you're unsure, what you can do is 31.5, do the inverse operation of the addition, just subtract 22.5. That equals 9, and that right there is equal to x. So just by a simple, sorry about that, divide, multiply, and then a subtraction, you've solved everything. Don't waste your time setting up the proportions if you don't need to. If the information is there for you to solve, take the scale factor route. Find the side length first, then find x, instead of using proportions to find x and then get the side length. Because when we're working with these, it just seems like there's a lot of information in front of us. But if you use that, you should be 100% solid gold. Now, the proportions will never fail you. I want you to use it on an SAT if it's not providing you enough information to take the scale factor route. But if you can take that scale factor route, take advantage of it. All right, go ahead, guys. I'm not going to take the long way home. We did it up top. It's a little more thorough down here. But go ahead, apply this. Take what you know, dominate and crush this thing. Everyone should go 9 for 9, corner pocket, hundo. Let's go. And for those that took the time to complete independently, here is your answer key. Scrolling through, for number 1, you should have had -18 and -33. For number 2, just applied a few of these that were given, and they all equal 2, so your scale factor is 2. For number 3, again, I used that number method. I came up with 019 is similar to 019. I circled C as my answer because 019 and 190 are not in the same order. Neither are 190 and 091. For number 4, it's giving us enough information for angle. They both share C, represented by that one arch. And then B is represented by 2, and same with E. So I went and circled angle. For number 5, which statement would justify triangle ABC is similar to triangle DEF? Okay, just by looking at it, 6, 8, 10, 21, 28, 35. It is side. Sometimes they'll make you go through each proportion to find that, but you don't have to. Just go ahead and take what you can identify and circle your best choice. All right, for number 6, solving for that midpoint, you should have had 5.5 and 3. We did -3 plus 14, 8 minus 2. That gave us 11 and 6. We divided each by 2. We got 5.5 and 3. Number 7, scale factor. All right, image over pre-image. Our image is our dashed line again, so we took 4. We put that over 10. We took 6. We put it over 15. We took our 8, put it over 20. They all came to 0.4. You only had to do it one time, just in case you chose a different one from someone else, just so you could see your own representation there, okay? For number 8, we took the long way home. We set up the proportion, cross-multiplied. I didn't write the statement this time as we did over here. Because I want us to get comfortable just knowing that, hey, it's x over 20 is equal to 18 over 24. Cross multiply, we had 24x equals 360. Divide each side by 24, we should have had x equals 15. Now, you also could have set that up differently. All right, you could have done it as 24 over 18 equals 20 over x. All right, you don't necessarily have to go with the side to start with, but as long as they're set up with the corresponding sides of each. But remember, if you start from the small triangle on top, when you set up your next proportion, you have to take the other side length from that small triangle and then set it over the corresponding side, okay, from the other. And for number 9, we just took the shortcut. And just to give you an idea of how simple this can be, all right, if we're solving for QT, well, this entire line here, all right, what that does is that they share, right? Angle Q, well, angle for QT goes from 1 to 3, and guess what? So does QR, 1 to 3. So all we had to do was take 22, because we're solving for that large triangle, divide it by 4. We got a scale factor of 5.5. All right, if you multiply that by the corresponding side that you're solving for, so we're solving for side QT, but its corresponding side is QR, which is represented by the 6. We multiplied 5.5 times 6, or scale factor times 6, gave us 33. Now, QT is 33, all right? It also says x plus 24.5, but we now know that it's 33, so we can just simply take 33 minus 24.5 to give us our x value, which is 8.5, and that completes the review. Guys,